Well, hello again everybody. Well, I'm sure that most of you will know that from time to time I like to make my own printed circuit boards at home, and an important part of that manufacturing process is to drill the holes through the PCB so that you can install the component legs through it. And up until now, to do that I've been using my trusty old Dremel, which is installed into a stand. But unfortunately, last time I used the Dremel, I did actually manage to break more than a couple of drill bits, and that was less than satisfactory. And so I ventured onto Amazon to look for some alternatives to my Dremel unit. So today we're going to do a review of that mini drill that I purchased, and perhaps we can also find out what the problem is with my Dremel and why we're breaking so many of those little mini drill bits. So this is my old Dremel high-speed multi-tool. Now when I'm manufacturing PCBs, I actually like to have the multi-tool installed in a stand here like this. So we're using this Dremel workstation stand. The number for those playing along at home, it's a Dremel 220 workstation. And the idea is that rather than using the Dremel freehand, just holding the thing and drilling holes in the PCB here, it's actually much easier to actually have it installed in this drill press adapter, and the reason being is it keeps everything absolutely vertical to the workpiece that we're drilling. Most printed circuit boards that are manufactured today are actually made from a material which is kind of a glass reinforced plastic. So within the plastic material there's some very tiny strands of glass. Now, as most of you probably know, glass is a really hard material. Now, a lot of the drills that we may have used at home are things like this little tiny twist drill here. I think this one's about 1.5mm diameter, but this one is probably manufactured from some kind of high-speed steel or a similar alloy. But the problem with using this type of drill with a fiberglass board like this is that the glass in it will very quickly, it'll blunt the drill almost instantly and make it useless for drilling holes. So if we want to successfully drill a lot of holes in our printed circuit board here, we need to use a type of drill which is much harder than the glass reinforced fibre in here. And the type of drills that we use are actually these ones. Now these ones are manufactured from a specialist material, and that's called carbide. I'm hoping that this set of drills here will show up okay on camera because some of them are really tiny. I think that one's maybe about 0.1 of a millimetre, maybe going up to about 1.5 millimetres in various steps. And for comparison, let me just see if I can stand up our 1.5mm twist drill there. And you really can see how much bigger it is compared to the 0.1mm carbide drill we have on the right. I'm sure that those of you watching at home will know that materials that tend to be very hard also have a tendency to be very brittle, and in fact that carbide material really is super brittle and it's really easy to snap a drill. And if you combine that very brittle material also with a drill diameter which is absolutely tiny like this, you're almost guaranteed to break drills. It's a perfect combination and often a recipe for disaster. I've removed our Dremel from the stand because I want to show you one of the problems that we have when trying to drill holes in a circuit board freehand. I've got this large twist drill here, and of course if I just look at the end of the twist drill, you can see that we've actually got two cutting edges. There's one on that side of the drill, one on the opposite side, and that's the part of the drill that removes the material. And of course a drill is meant to be used vertically. It's meant to be presented at 90 degrees to the workpiece, and when the drill is being forced into the work vertically, it's kind of like a supporting column on a building. The drill itself is actually very strong. Maybe I can give you a better example of the problem by replacing our large twist drill with a piece of spaghetti. So I've got a piece of spaghetti here and I'm presenting it vertically to the workpiece. I just hold it midway. I'm just going to put my finger on top of it there. I'm going to push down. I can actually push down quite hard. So this is the way we should be using our drill. It's being presented absolutely perpendicular to the workpiece. It's at 90 degrees. So I'm actually going to present our drill now not at 90 degrees. And if I now push down now, the piece of spaghetti just snaps because it's not strong. What happened there is we tried to bend our piece of spaghetti, but because a piece of spaghetti is just so brittle, it just snaps. And we're going to have just the same problem with our actual real carbide drills. We have to present them to the workpiece absolutely vertically, and if we don't present them vertically, there's a good chance we're going to snap our very tiny drills here, and that's why we use a drill press. As you can see, I've reinstalled the Dremel into its drill press stand, and in theory we should be good to go now for drilling those PCBs, or so you would have expected. However, when I have tried to use this stand, I've actually still ended up breaking quite a lot of those carbide drills, and I wasn't sure why, so let's investigate a little bit further. In the chuck of the Dremel, I've installed a piece of precision ground tool steel. Now, touching the side of that piece of tool steel just down here, you can see that we've got a dial test indicator set up, and when we actually lower the drill press, we should be able to see whether or not this piece of steel is actually being presented vertically, because on the test gauge it really shouldn't move very much at all. So I've gone ahead and I've zeroed our dial test indicator. Unfortunately, you might be getting some glare from my lighting here. Nothing I can do about that. But what I'm going to do is I'm just going to very slowly, I'm going to just press the lever onto the drill stand down. And in theory, the gauge really shouldn't move at all. So as you can see, as I actually move the hand lever down, we're getting a reading here on the gauge, and it actually appears to be going about, well, maybe its worst case is about 0.2 of a millimetre. Now 0.2 of a millimetre might not sound very much, but when the drill might only be, well, I don't know, maybe not much more than 0.2 millimetre of a thick, that's actually quite a large amount of movement. Now, I'm not exactly sure where that movement's coming from. Basically, this whole plastic assembly, it really just isn't rigid enough. It isn't just in the whole rack and pinion slide arrangement, because even if I don't lower it, I just kind of put my hand onto it here, you can see that everything's moving. Now, you might have said, well, maybe some of these clamps on here which hold everything together, maybe they're loose. Well, they're not loose. Everything's actually really tight. Unfortunately, just the whole assembly just isn't particularly rigid, and it can allow the Dremel, the actual drill mechanism, to slop around. Again, just even tiny amounts of pressure on here just moves everything by just a huge amount. Now, most of the movement that we're getting does seem to be on what I'm going to call the X arrangement. If we just spin this round and put the dial test indicator on the front, it's not quite as bad. Let me show you. Now, as you can see, now we've actually moved it into what I'm called the Y arrangement. It's actually on the front of the steel bar rather than the side. In fact, we've only got a run out here of about, I don't know, I'm just guessing, maybe about 0.04 of a millimetre. Really not very much at all. So I think what's going on here is our Dremel is actually tilted. It's actually cocked off to one side slightly, pulled over like that. It's not sitting vertically within the stand, but there's a few problems going on. When you actually pull this down like this, pull the lever down, it does actually seem to somehow slightly distort the plastic housing, which again makes this whole assembly kind of slide to one side. Now, the actual sliding assembly itself, it's quite crude. It's got an awful lot of slop into it, which just moves around, which isn't ideal. In theory, if we just turn this around, we've actually got this adjustment screw here, which I undo that. I think I undo that one. We can actually twist this around, kind of move it. So you would think in theory we could actually set this so it was totally vertical, but as you can probably hear, it goes into these click positions, and that is meant to be vertical. The reality is that isn't vertical, it's slightly out. And because it clicks into these defined positions, there's nothing you can do just to slightly pull it over. So that's certainly part of the issue that's going on with this stand. So our Dremel device sits in this plastic basket, and it's actually secured within the basket. There's actually a captive nut which I'm just spinning here. Hopefully you can see that. Now, the Dremel itself sits in the basket, but in theory it should register on a piece of flat material here at the bottom of the drill, but there's hardly any material. It's just a very tiny edge. So I actually think part of the problem is just the lack of precision in this plastic moulding, but because it's just balancing on this little edge here, it allows the whole tool just to rock around within the basket, and it's just not very secure. So I think that's a problem. But again, because they're housing and a lot of this assembly is just manufactured from plastic, there's just too much slop in everything and the materials just aren't rigid enough. Now in theory I think there might be some adjustment here. I can see a little screw there, and there's also maybe one down there, and I suspect that that screw goes onto the side of this rod here which is slotted, so that might be some form, I might call it a gib strip. It allows you to maybe just take out some play. But I don't actually think the play is there. The play is actually in the whole plastic assembly. Everything is moving rather than just this steel bar. So there's just a combination of things going on, just a general lack of rigidity. And unfortunately, I don't think there's very much I can do about that. While I've got the dial test indicator available, we might as well just check to see how well our drill is centered within the chuck. Now in theory this is a collet chuck, so it should be very accurate. Let's just check that. So I've set up the dial test indicator and I've got the tip of it just under where the steel bar emerges from the chuck, and I'm going to try and spin the chuck now. Unfortunately that is quite difficult because this whole setup lacks rigidity, and just touching the Dremel just throws everything out. But let's try and turn it. So what I'm going to do is I'm just going to keep turning this, then take my fingers off, let it settle, find out where the worst reading is. Okay, I think that's about there. So it looks as though we've got, at worst case, about 0.1 of a mil of run out. So there is perhaps a little bit more run out than I would like to see, but I'm not actually here to hate on Dremels. I bought this Dremel back in 2003 and I've got to admit it's had quite a hard life. I'm sure it's been dropped on the floor more than one occasion, so it could be that the whole armature within this Dremel could be slightly bent because it's been dropped. Or maybe this chuck that I'm using, again it's an old chuck, it could be slightly worn. I'm sure that most people using a Dremel probably won't have any problems with either the Dremel itself or in fact using this stand. It's only the fact that I'm using these carbide drills that's causing me a problem. Certainly wouldn't be a problem using much bigger drills. So there's our low speed, which is actually coming up about 18,000, so slightly high. Of course this motor's unloaded at the moment, so if we were to actually drill something maybe it'd slow down quite a lot. Let's go to the maximum speed now. It's about 32,000 RPM, so just under its full rated speed of 33,000.
The driller killer is coming.
I've moved the Dremel to one side so we can take a close look at this mini drill that I've gone ahead and purchased. So this one, I actually bought it from Amazon. I think it was sold under the Katsu brand, and from memory it was about £70. We've actually got a 9-page instruction manual, and we've also got a teardown picture of it, complete with all different spare parts, which I'm sure are probably totally unavailable, but we've got a construction drawing anyway, should we need to go in there and repair anything. Yeah, the manual looks fairly good quality for what it is. So starting off, I can see that we've got some motor brushes. I'm hoping that they're actually spare because we don't really want to go ahead and install any just now. We've got an Allen key for assembly. We've got a chuck key for a Jacob style chuck, and we've got what I'm guessing is some kind of a drive belt. Feels quite stiff for a drive belt, but I think that's what it is. So immediately into the meat and drink of it, we've actually got a cast iron base, not aluminium. I'm actually quite surprised how heavy that is. That is actually pretty solid. Can't really tell how flat it is, we will check that later. We've got a length of steel bar here which is threaded at both sides, so I'm guessing we can screw a knob on there. And I think this is probably going to be used to actually move the quill up and down on the drilling machine. And here I can see we've actually got the machine itself, so it really looks as though it just comes in two parts. We're just going to have to install the base on it. And that's probably pretty much it. So just looking at the machine head here, you can see that we've got a column which actually allows the machine head just to slide up and down. Now looking at the column, it is actually a piece of tubing. Of course I would have preferred that to be a piece of solid steel bar. I suspect you could probably buy a steel bar. I would have liked to have seen a solid steel bar just because it would have made everything a little bit more rigid and a little bit heavier, which just helps with damping down any vibration. Looks like we've got a simple spindle control here, which I'm guessing is going to be some kind of electronic speed control, very crude no doubt. And we've got an on and off switch. So using the tools provided, let's go ahead and assemble it onto its base here. I just want to make sure that the tube here isn't sticking out the bottom of the casting, because it would probably cause it to rock. So I'm just going to pull it back up a little bit. Yeah, it is recessed that. Let's just nip it up with these Allen screws. So we've got this handle here which we can use to lock the head of the drilling machine on this vertical column, and it's also got another bolt here which, well, I'm guessing it is just another adjustment to keep this clamp together. That's actually very loose at the moment, and I think we could probably benefit from tightening that one up a little bit, so I think we might just do that, because I'd rather this moved up and down there with just a little bit more friction than what it has at the moment. So I've tightened it up a little bit too much. Let's just swank it up a little bit. I think that will do. I wouldn't say that this locking arrangement really inspires confidence. See, I put quite a lot of force on there trying to tighten that up, and it's still slipping around. Let me have another go. Yeah, it does actually work, but you've got to have had your Weetabix, and I'm actually thinking that ideally you would probably be better locking both of these up as well. As I mentioned earlier, these machines do go via a variety of names. You can see that this one says Surum on it. Certainly I have seen some that are marked up with Katsu, but it says Surum Mini Drill, and it's by the B King Co., which I guess is a Chinese company. And I can see that we've actually got 3 speed ranges. We've got what they're calling 0 to 8,000, 0 to 11,000 and 0 to 16,000. And I'm guessing that really to drill PCB type materials we are going to want this on the high speed setting, which is 16,000. And the way that our drilling machine is going to achieve these 3 different speed ranges is via some form of pulley arrangement, which is going to be under this cover, I'm guessing. So I can see that we have got a little clip here, so if I press that, does that come off? Does it hinge up? Okay, it looks like we pop it off on both sides. Oh, we can actually see it has actually come with a belt on it already. So we can see that in the packaging material they do actually give you a spare belt in case this one burns out, which is nice. And under the cover we've actually got this stepped pulley, and that's actually on the motor and also on the spindle of the machine here. So we've got 3 speeds, so of course we've got 3 steps in our pulley. So just looking at how we've got it set at the moment, on the motor we've got the actual smallest pulley selected, and that's going to the biggest pulley on the spindle of the machine, so that's going to give it our lowest speed. And then if we want the highest speed, we've got to take this belt and we've got to move it up to the top here. Now it looks as though perhaps the way that we do that is there some stretch in it. Yeah, there is actually a little bit of stretch in it, so we don't actually have to undo anything, I don't think. We can just manhandle it. Okay, so we've actually put it onto its top speed now, but I don't know, just for the initial switch on, I'll tell you what, we will actually go a bit lower. We can see that the housing of our motor here, it's actually constructed from just red plastic, so it's not a metal motor, so I wonder if that'll heat up or get hot or melt. Guess we'll find out. And we can also get access to the brushes here. So we've got a little cap on this side to get access to one brush, and there's also another cap on the other opposite side of the machine here to get access to the other brush. And I can actually see into the motor, and those brushes, I I think they are installed at the moment, so the machine should be ready to go. And I think that the plastic motor, it's actually hung off this bracket here, which has got some slots in it. So if you actually did want to just make it easier to move the belt, you could actually just slacken these 3 screws off, which would allow you just to move the motor on its slots. And I guess the other thing you could do is you can actually just move it back and then just lock it up afterwards, just to make sure you've got the belt at the right tension. But I don't know, that kind of feels okay to me. You can also see we've got the speed controller here and the on and off switch. And also just noticing that unlike some of my bigger drilling machines, there is no form of interlocking here, so if you really wanted to, you could actually switch the machine on with this motor cover open. In fact, I think that's a more interesting thing to do, so perhaps we'll try that first. Now, is that on or off? I think that's probably off. Should we turn the speed down a little bit? Yeah, we'll try that. So let's try switching it on. Oh, you can actually hear it ramping up. I actually quite like that, that's quite nice. I think I almost want to operate it with that cover off, it is more interesting. Now, interesting enough, that belt's actually quite warm after running. I wonder if that's just because it goes through a tight radius or it is slipping slightly. Not sure, we'll have to keep an eye on it. If it does get too hot, it is a plastic belt, it's going to melt it. And I can also see that we've got a depth stop gauge here, which appears to be adjustable via an Allen screw, which is, of course, that's not particularly useful. Maybe we could put a little knurled control on here if we needed to, but yeah, that's okay. Now, I'm not at all concerned about the accuracy of these 3 speed ranges, but I guess we do need to just keep them honest and make sure that the maximum speed is going to be suitable for high speed drilling. So to do that, I'm just going to use my tachometer, which is one of these little laser non-contact devices. So let's stick that on there. Now, of course, we are on the lowest speed at the moment. Let's fire that up and find out. So we're getting a reading there of about 3,800, let's put that up to max. So I think that was about 8,500, and of course that was actually the free running speed. If you were actually drilling something, it would bog down quite a lot. Let's put it up a speed. I'm sure it would be good practice to actually unplug this before you change the speed on the belts, just in case you accidentally switched it on, but of course, yeah, I'm not going to do that. Let's have another go. So I think that was about 11,000, wasn't it? It did actually seem to change speeds a little bit on its own there, not sure why. And let's just go for its top speed now. So I think we were getting about 14,000 there, weren't we? So maybe just under its top speed, but I'm not dead sure I was aiming the laser quite in the right place, but certainly it's in the ballpark, isn't it? So we can lower the quill on our drilling machine by pulling this handle down, and I've got to admit this machine does seem to have come from the factory and they've pre-filled it with grit or sand inside this sliding bearing arrangement here, because it does actually feel very rough inside. I think where that feel of roughness is coming from is that you can see that where this actually slides out, it's on some form of bearing here, but the surface of this has been ground. Now I can see it's nicely ground on this face and it's nicely ground on the other face here, but on this side and this side it seems to be missing. So I think what's gone wrong in the manufacturing process is probably when they made this shaft, they actually made it more or less size for size. They didn't put any spare material on it to actually grind away. So because the tolerance of the casting isn't perfect, it's slightly undersized. So the actual grinding wheel has missed it. And because it has missed it, we've kind of got what feels like a bit of a rough casting here, and then a lovely polished surface here. You could perhaps clean that up a little bit with a bit of emery to improve it, I guess, if you wanted to. I think it does actually feel better just for giving it a wipe, so maybe, I don't know why they do it, but often we get these Chinese machine tools and sometimes they do a good job of machining, but they don't actually clean them off after they machine them, so they're full of bits of metal swath. And yeah, I think maybe I've actually just wiped some of that away because it does feel slightly better already. I'm not sure it'll come out very well on camera, but there is actually kind of a pressed in bearing down here. I thought that this quill was kind of just running up and down in the rough aluminium casting of the head of the machine, but no, it has actually got some kind of a proper sliding arrangement. Now when I've investigated this roughness a little bit further, what I can actually think I'm feeling is that there's actually a rack and pinion down here. Can I get you in? Maybe, not sure. So I actually think that the roughness that I can feel is actually from this rack and pinion here, because having just put my finger in it, it seems to be quite dirty, but there's also no lubricant at all there on the actual rack and pinion drive. So I think maybe again a little bit of grease might just improve that. So what I'm going to do is I'm just going to put a rag down there. I'm going to clean some of the old machining swath out of it because I think it is a little bit dirty, and we'll go ahead and we'll re-grease it and see if it's improved at all. So internally I've just given our sliding surfaces just a wipe over, and I've applied some new lubricant, and yeah, it doesn't feel too bad. I'm certainly not going to say it feels great, but it's a big improvement on what it was. I think part of the feel is actually down to the actual pinion gear, which is working against the rack, is quite crudely machined. In fact, I'm not even sure if it's just cast, and I think it's actually, that's what you can feel. But I've got to admit, the more I'm using it, the more I seem to be well, I'm going to say it's either bedding in, more likely I'm just getting used to it. Now I'm sure some of you might be wondering what's the maximum depth of a hole that you can drill. I'm not sure, so let's just find out. So I'm just going to zero my calipers there and just extend that. What have we got? Okay, so we've got 22 millimeters there. So the maximum depth at the hole that you'll be able to drill is, well, probably just under 22 millimeters. As you can see, I've gone ahead and I've got our dial test indicator out because I'm just going to repeat some of those same tests that we did on the Dremel. The first one, just making sure that the actual, when we actually lower the quill, when we actually extend it, want to make sure that it actually runs true and it's not actually running off to an angle. So we're just checking that this piece of precision rod, it should be totally perpendicular to the table, and we shouldn't get any indication on the DTI when we pull the handle down. Well, what can you say? You can't really get any better than that. We're not getting any deflection whatsoever. So I think the Dremel, that was out by about 0.2 of a millimeter. This isn't out by even 0.01 of a millimeter, maybe something like 0.0005. Absolutely tiny amount. That's really good. Let's just try it in the other plane like we did with the Dremel. So with the dial test indicator installed at the front rather than the side of our test piece, we can see that we are getting just a little bit more of an offset, but it's still a relatively small amount. I think the maximum we get in there is about 0.02 of a millimeter. So again, much better than our Dremel. Okay, and I think our maximum run out, again, it is beating the Dremel. We're getting 0.002 of a millimeter, so that seems pretty good. The actual Dremel uses what they call a collet chuck, which is much more accurate. A collet chuck doesn't have any moving parts inside, unlike a Jacob style chuck like this one. So Jacob style chucks, they're not known for being particularly accurate, so it looks like we might have got lucky with this one because, yeah, seems really good. Now I don't know what you guys think, but so far I'm really not finding very much to hate with this mini drill. I guess the question is, how well will it drill some PCBs? Let's find out. So into our Jacobs chuck here I've installed a 0.65mm drill, and I've got the drill set to its maximum speed. So let's have a go at drilling our first PCB. So let's see how we get on. Well, I have to say, it's one of those things that maybe you have to feel, but that is just an awful lot better experience than using the Dremel. So much better. So previously when using the Dremel, when you actually lowered this, the actual spring pressure was quite hard on the return, and it actually felt, I don't know, very vague. You didn't get a lot of feedback when you were drilling through the material. Now, another name for a vertical pillar drill like this is called a sensitive drilling machine. And the reason it's called a sensitive drilling machine is you can actually feel the cutting action of the drill as you actually push it through the work. And I'm actually getting really good feedback from the drill as it cuts through this PCB material. And again, just the whole setup is so much more rigid. It just inspires confidence, and I really don't think I'm going to break any more drills. Let's have another quick go. Okay, so using this drill press over the Dremel, it really does inspire confidence in drilling through that PCB, and because it does inspire confidence, you're not constantly worrying that you're going to break the drill bit, so you consequently can actually drill a lot more holes an awful lot quicker. So even though the maximum speed of this is only about half that of the Dremel, I actually think it's still really good. I just want to find out what the maximum working height is between the chuck and the actual table here. So let's just give that a quick measure. Now I'm going to check this quite crudely. So that looks like it's about, maybe about 140mm. So 14 centimetres, or about 6 inches. Now while we've got the drill in its elevated position, we might as well just see what the maximum capacity of drill is that we can chuck here. So I'm just going to open up our Jacobs chuck. So let's start off with a 5mm drill. Okay, that goes in there no problem. Let's jump to a 6. Yep, 6 is no problem. Let's see if it will take a 6.5. No, so it looks like the maximum drill that we can actually chuck here is a 6mm drill. Now just because we can install a 6mm drill into our chuck here, that doesn't actually mean we should actually use a 6mm drill. Now there are various formulas for working out the speed at which the drill should run at. Now most of those formulas were actually derived from the production environment, where of course time costs money, but if you actually spin the drill too quickly, you'll generate a lot of heat in the tip of the drill here, and you'll actually blunt it, you'll actually melt the surface, you'll damage the cutting edge, and you'll blunt the drill very quickly. However, when we're using very small drills like these PCB drills here, which are made from cobalt, really you can't go fast enough. And that's because they're actually manufactured from this very hard cobalt material, but also because the actual size of the drill bits, they're just fractions of a millimetre. They're very small, and really you cannot go too fast for these drills. Probably a typical speed range would be anywhere between about 30,000 to 100,000 revs per minute. So typically you're not going to overspeed these drills with the equipment that you've got at home. So to do our drill test, I've installed a 3.5mm drill into the chuck, and I'm actually going to set the drill to, well, to its lowest speed range, because really even with a 3mm drill the maximum speed that it's recommended is about 1500. So speed range 1 goes up to 10,000, so the problem won't be trying to actually spin this drill too quickly. The actual problem is going to be, can we actually spin the drill slowly enough so we don't cause it to overheat and blunt. Now I'm sure that there isn't actually any calibration for the speed control in our drill, so what I'm going to do is I'm just going to switch the drill on. I'm going to adjust the speed control for what I think's about right. So that's the lowest speed we can do, so let's just try it in our piece of wood. Well, okay, does bog down quite a lot there with a 3mm drill. In fact, we stalled it, so perhaps we need to go a bit faster. Okay, certainly that presents no problem. One thing you'll notice with these very small electric motors powering this drill, that have a very crude speed control. The characteristics of the motor mean that it really isn't able to generate a lot of torque at low speed. So you could see that when we were drilling this piece of wood, which is actually quite thick, it's about 20mm thick, as we actually go deeper and deeper into the wood, the actual drill requires more and more torque to maintain the speed, and we actually found that when we had the speed controller set to the very low speed, it actually stalled the drill, so that necessitated going a little bit faster. But if you do increase that speed a bit, certainly don't seem to have any problem. Okay, let's try again. Yeah, that works fine, no problem. The next thing I'm going to try is this quite heavy aluminium plate. Now this aluminium plate is about 6mm thick. And I'm going to use some cutting fluid on here because the problem with aluminium is that it's quite a sticky material, and one thing that you'll find is that that sticky material can build up on the drill tip. That can actually generate a lot of heat, and it can actually wear the drill out much faster than it should. So we just put some cutting fluid on there. Let's try it, let's see how we get on. Yeah, no problem. Probably could even go a bit faster maybe. Yeah, go straight through there, effortless, no problem at all. And the final test that I'm going to do today is a piece of, I don't know, that looks like about 3mm steel. This might be a little bit tough for this little drill, so let's give it a go. Yeah, okay, that was screeching a bit there. It actually was cutting quite well, but I'm sure I was going much too fast, so I'm going to back off, I'm going to slow it down. Yeah, not enough torque, let's increase the speed a little bit. Yeah, okay, I would say it's struggling a little bit with this 3mm drilling steel. You can do it if you peck away at it, but the problem is the drill's just too fast, and it actually hasn't got enough torque when we turn the speed down. But you could nurse it through, I've got no doubt. I might just try a smaller drill, because I'm sure it will get through this. So I've gone ahead and I've swapped out our 3.5mm drill for a drill that I think is about 1mm. I suspect we're going to do a lot better with this. Let's give it a go. Yeah, no problem. I bet we can go faster. Yeah, that works absolutely splendidly. So if you're actually just using small drills in this drill press, which it's designed for, absolutely no problem, definitely recommend it. Now, because of the high-speed nature of both this Dremel and this Surum mini drill, they're going to be quite noisy to operate, and I think that I would recommend using some ear protection, because the noise level given off by both of these, I think it's very quickly going to get tiring. But I thought we could just do a little bit of very crude comparison, try to set this noise level meter midway between the two. Let's switch it on, let's see which is the loudest. Let's start with the Dremel first, we'll put it up to maximum. Okay, so I think that was about 20 dB for our Dremel. Let's start up the Surum, which is also set to its maximum speed, and we'll give that a go. So the Surum drill was actually about 16 dBs there. Now, because this is a logarithmic scale, the actual Surum is an actual awful lot quieter than the Dremel. Now, for some people using drills at home, perhaps the loudness of the drill could be important so you don't disturb the rest of the household and your neighbours, but I would still recommend maybe just using some ear protection. Now, in summing up which of the two drilling machines do I prefer, is it the Dremel when it's installed into its work stand, or a little Surum high-speed mini drill? Well, I don't think you're going to be surprised. I'm going to say that this Surum mini drill here, it actually wins hands down. It's much better to use, the tolerances are much higher, the actual sensitivity when you're actually lowering the drill into the material, it's much better than the Dremel workstation here. Now, I'm not going to hate on Dremels too much, because obviously the separate Dremel installed in a stand does have more utility, because perhaps you can always take the Dremel out and use it freehand, and a lot of us do that. I've certainly done that many times, but unfortunately it's the quality of this work stand that really lets the Dremel down. It's just not rigid enough, it's constructed from plastic, it's just really poor. The actual Surum drill, the actual build quality, I'd actually say it's really good. Now, I'm not sure which of the two drills will last the test of time, because, as I said earlier, I actually bought this Dremel in 2003, so, it's more than 20 years old, whereas this one I just bought a couple of weeks ago, and I've really not used it very often. But, yeah, so far so good. I think this is a good little unit. Now, the price point for this was about £60. Well, you can't even buy a Dremel for £60, so comparing it that way, I actually again think the Surum is really good value for money. Now, as much as I like this Surum mini drill, there's probably a few things that I would do to improve it. The actual construction of the column here, I said at the very start of the video, this is just a piece of tubing. If I was going to use this a lot more, I think I would either do one of two things. I'd actually replace this piece of tubing here with a solid piece of steel, which would be about 32mm. I had a quick look on eBay, and you can buy a 300mm length for just over £12. That would be a piece of ground steel. I'm sure that that would actually be a lot better. It would not only be more rigid, because of the extra mass and weight in the whole assembly, it'd probably run a little bit quieter, and it would be more rigid. That would be an improvement. Another thing that you could also do is, if you happen to have an old bag of concrete at home, what you could actually do is you could just fill this column with concrete. Again, that would actually add some weight and make it again just a little bit more rigid. The actual height adjustment here doesn't work brilliantly. I think the idea is you can just undo this lever and rise it up and down, but the reality is you have to undo this lever, and you've also got to install an Allen key here and actually adjust them both. Otherwise it tends to get stuck or it doesn't move at all. So yeah, that doesn't work brilliantly, but I suspect a lot of people, they're going to set it to a height and then leave it there. Certainly that's what I'm going to do. I think there's also some interesting modifications you could do to the Surum. I think one thing that I would do is I would add some form of light pointing down onto the workpiece. That'd be a nice little project. And I think if I was doing a lot of PCB drilling, I'd probably buy one of those really cheap USB microscopes and again install it just looking at the PCB board down here, because my eyes are getting a bit older now and I struggle to drill some very small holes. So I think some magnification would help, as would a bit more light. But in general, yeah, I would actually recommend this machine. I think it's a good bit of kit and it's good value for money. So I think for my review of the Surum drilling machine today, that will do. So until next time, look after yourself. Hope to see you again very soon, but until then, bye bye for now.